Alright, we are here at page 2 of 4.1. We're learning how to graph linear equations in two variables, meaning instead of just plain old x, we're going to have x and y involved. And we hinted at this in the beginning of chapter 3 when we had story problems that had two things we were trying to find, two unknowns. And I talked about in class and also in the videos that when you get to Math 65, you're going to keep both of those variables in those story problems and learn how to solve what's called a system of equations. But to have that kind of skill, we need to learn a little bit more about just the equation itself that has both x and y in it, and they're known as linear equations. So keep the goal in mind here in chapter 4 is to get good at graphing linear equations, to understand what a linear equation is, and we're going to get really good at graphing them. So we're still just working on some graphing basics here as we start 4.1. And this set of problems will have you give the ordered pair for the points labeled in the figure. And again, the ordered pair is like the address of where the point is on the graph. So the ordered pair is like the address of where the point is on the graph. And it has two pieces. It has an x-coordinate and a y-coordinate. And order matters here. X always comes first. So as we identify here now, we're not plotting. The points have already been plotted here. We're now giving the coordinates, or the ordered pairs, for those points. So they always come in parentheses with the comma in between the two, and you're going to have your x value and your y value. And they're going to be positive or negative based on which direction we're traveling from the origin. To the right is positive, to the left is negative. Up is positive, down is negative. So as we locate point B here, you look to see first, did it go left or right from the origin? How would we get there from the origin? You're basically creating a little roadmap for somebody. So we went 2 to the left, so that's negative 2. 2 to the left. Then from there, we went up 4, which would be a positive 4. So the coordinates for B are negative 2, comma 4. Or if you want to write the positive in there, you can. The positive is understood to be there when you don't see it. Okay, so it could be just negative 2, comma negative 2, comma 4, and that means the same thing. Okay, this is the point negative 2, 4. Okay, we'll come back to C. That'll be a try problem for you. Let's look at D. D is down here. And how do we get to D? Again, we're looking to create the x and the y address here going from 0. 0, 0, the origin. So if we're here at 0, 0, we would have to get to D first. Our left or right comes first, our x value. 1, 2, 3, 4 to the left. So it's negative 4. Then from there, from that point, 4 to the left, you would go down 1. And left is negative, down is negative. So it's negative 4, negative 1. That's the address of that point D. Let's look at F. F is actually lying on the y-axis here. And if you remember from plotting, that means one of the values is 0. Okay, so let's look again to see how we're going to get there from the origin. So you start at 0, 0. And you first ask yourself, did we go left or right? No, we didn't go anywhere. You're staying put, okay? So you start by staying put, which means that you don't go anywhere left or right. There's a 0 coordinate for your x value. And then, to get from the origin down to F, you would go down 1, which would be that negative value here. So this coordinate is 0, negative 1. 0, comma, negative 1. All in parentheses. So the point for F is 0, negative 1. Now you try point C, which is up here in this second quadrant, and point G, which is down here in the lower right quadrant, known as the fourth quadrant. Hit the pause button, come back when you're ready to check your coordinates. Okay, for point C, you should get the coordinates of -6, 5. Again, in parentheses, that's our notation for a coordinate. It's always x, y in parentheses. Order matters, that's why it's called an ordered pair. And then for G, you should get 5, -3. Okay. And points A and E are assigned in your practice sets. You can try those for your homework. So we're going to keep the goal in mind. We mentioned it up here, but what we're doing is we're learning to graph linear equations. And what that means in terms of why are we drawing that graph, what we're doing is we're really drawing a line that gives us all the solutions that make the equation true. So we're drawing a line of all the solutions that make the equation true. Now let's kind of recap what we've done so far in this algebra course. Up to now, we've only had one variable, maybe something like this, 5 equals 3x minus 2. And we said, what is the value that will make this true? What is the single answer that will work? And so the way we phrased that was we would say solve for x. And what you'd come up with is you would get one answer. In this case, the answer would be the solution set x is equal to 7/3, okay, if you were to solve that. But in some cases, you might end up with a false statement when you tried to solve it, or a true statement, like 0 equals 1. That would be an example of a false statement. Or 1 equals 1. That would be an example of a true statement. The x's fall out when you tried to solve. So either you got a single answer, or you got a false statement or a true statement. And for a false statement, you would say no solution. For a true statement, you'd say all real numbers. And the capital R with the double line there is a symbol that's used to mean all real numbers in mathematics. We're definitely ink savers. I personally believe it comes from the age before paper, when all math had to be chiseled into stone, and I think right away we came up with some good symbols to make it simpler. I don't have any facts to back that up. I just like to think that's why it happened. It just makes sense that way. Okay, so up to now is just one variable, but now we're going to be introducing two variables. There's going to be two possible, two unknowns. So now we have x and y in our equation. And instead of 5 equals 3x minus 2, we're going to say y equals 3x minus 2. And what we're looking for is a value for x and a value for y that make this equation true. Okay? So now with two variables, we're looking for a pair, a value for x and a value for y that makes the equation true. And I think I might be off the screen here, so I'll pull that up a little bit. Now we're looking for a pair where you have a value for x and a value for y that when you plug them both in, it makes the equation true. Okay? What that creates is an ordered pair. Now there's three forms to the linear equation, and we're going to get familiar with each of these as we go through this chapter. The first one is known as the standard form, and we've sort of gotten used to this a little bit. We've seen it a little bit. We just haven't called it that much yet. But standard form, ax plus by equals c, where a is a number, b is a number, c is a number, and your two variables there are x and y. In fact, I'll just highlight those in red here. Okay, you're always going to see that both variables x and y in a linear equation now. But then there's the slope-intercept form, and this one looks like this: y equals mx plus b. For those of you that have taken algebra before, this one might sound very familiar too. And again, I'm going to highlight the variables in red. So m becomes a number, b becomes a number. The idea of slope, intercept, one's your slope, one's your intercept, that might come back to some of you as you start reminiscing about, hey, I think I've seen these before. And finally, let me make sure I'm still on screen with that. Oh yeah, I'm pretty good. Okay, finally there's the point slope form, and this is how we'll finish our linear equations at the end of chapter 4 here, is with point slope form. And it looks like this: y minus y1, whoops, I should have used a different color. Y minus y1 is equal to m times x minus x1. And again, I'll highlight in red. You'll always see the y as a y and the x as an x, but the rest of these will be numbers. This will be a y coordinate that is involved on the line. This will be an x coordinate of that same point that's involved on the line, and then your m will be your slope again. So it's a point slope form. It involves a point and the slope. This involves the slope and the intercept. This is the standard form. Everything's kind of in its proper place. The capital letters kind of remind you that this is the formal version. In fact, as we go through the chapter, I'll start talking about these as your formal version. This is your friend. It creates instant graphing possibilities here. And then this is kind of your fallback, your last resort. If you can't get anywhere with the information they've given you, you can use point slope form to try to get to where you need to go, either with the graph or solving or whatever it is they're asking you to do. Okay, so that's just some more basics here in terms of ordered pairs and now types of forms of the linear equation. And at the bottom of the page in our next video, we're going to look at what does it mean to be a solution to a linear equation that has both x and y, two unknowns, two variables. Okay, we'll see you there at the bottom of page 2.